Welcome to the Work Done Right podcast, where we talk with industry professionals to discuss best practices in construction, manufacturing, and maintenance. I am your host, Wes Edmiston, Director of Product with Cumulus Digital Systems and 15-year construction industry veteran. Hey, Work Done Right fans. This week we have a special edition of the podcast where Megan Golden, the Chief Business Officer of Cumulus, interviews past Work Done Right guests Matthew Kleiman and Mark Littke. They discuss the recent Boeing quality failures and how this translates to oil and gas. Given the history Matt and Mark have in aviation and energy, this should be an especially insightful discussion on the overlaps in the industries. I hope you all enjoyed the episode and stay tuned for more like this until the launch of Season 2 of the Work Done Right podcast. Now, onto the show.
Hi, I'm Megan Golden. Welcome to the Work Done Right podcast. On January 5th, 2024, Flight 1282 from Alaska Airlines took off from Portland, Oregon, scheduled to arrive in Ontario, California. Unfortunately, this flight did not reach its destination. Shortly after takeoff, a large hole was created in the side of the plane when a rear panel blew off. Luckily, the flight was able to land safely with no loss of life. However, a boy seated near the hole in the plane had the shirt ripped off his back before the cabin pressure was able to stabilize. This incident is the subject of a federal investigation and is understandably getting a lot of media attention. However, it has also drawn a spotlight into industrial work quality in the broader sense, and that is what we're here to talk about today. What is the root of quality problems in industry? Why are bolted joints in particular so critical and error-prone? How can leaders in industry and government prevent these types of accidents in the future? In this week's special episode of the Work Done Right podcast, we examine the answers to these questions and more. I'll be speaking with two experts who have extensive experience in the aviation and energy industry. Mark Littke, Chief Commercial Officer at Cumulus and a former Boeing engineer, and Matt Kleiman, CEO at Cumulus and a former leader at both Shell and Draper Laboratories. Mark, Matt, thanks for being here with me today.
Great to be here, Megan.
Good to be here.
So the first thing I want to get into and really kind of examine is just bolted joints in general. So to the average person, tightening a bolt seems like a fairly straightforward process. So why is it such a critical part of production, and why aren't we getting it right?
It does seem pretty straightforward, and I think from the surface or from an outside perspective, we hear this a lot, that it's just tightening a bolt. You might tighten a bolt you might replace the wheel on your car, and you just push it until you can't push anymore, and that's considered good enough. But when you look at some of these industries, aviation, oil and gas, wind, whatever these sort of critical industries are, the machinery, the components, the piping, whatever it happens to be, there's specifications around how tight, if you will, these bolts have to be. And it's for not only the kind of long-term life of the equipment or the pipe, but it's also because it's a piece of a larger system. And so there's typically either an equipment vendor or a maintainer will have a specific procedure that needs to be followed. And the whole goal of those procedures is to make sure that the integrity of them, of this tightening is right. So what's critical about them versus kind of what the outsider would see is that requirement to hit a specific number, to have everything put together and aligned correctly. And if that doesn't happen, typically, because it's a big piece of a large system, and if one little piece is not right, then it affects the rest of the system and the overall operation. So I think the perception is, again, it's very, very simple. You just turn the nut until it's tight, but it isn't like that, and that's on purpose.
Yeah, and I think another thing that's often surprising to people, it's not only a question of loose bolts. That's what we've been hearing a lot about in the media with the Alaska Airlines example. But in these critical applications, it's important that they're neither too loose or too tight. So they really have to hit a specific level of tightness, which is often called a torque value, a level of torque that you put in the nut. So there's three ways that you can assemble something, and this is broadly. You can weld it together. You have various types of adhesives that you could basically glue something together, or you use a fastener, like a bolt, to put things together. And bolted joints are everywhere, and Mark kind of alluded to this. Whether you're thinking about a wheel of a car or a refinery, a chemical plant, an amusement park, a wind turbine, really they're everywhere, and these are often critical. So an example of where sometimes these things go wrong, you could have a data center with a lot of high voltage power lines that are coming in to power the data center. And those power lines are assembled to the equipment with what are effectively bolted joints on something called busways. And if they are the problem there, obviously you don't want it too loose. But if they're tightened too tightly, then the wires are going to start to come together more than they should, and then you get overheating, potential electrical fires. So you're looking at both the under torquing, so not having loose bolts, and the over torquing, which is when you do it too tightly.
All right. So let's dig into the second part of that question. As you guys explained, it is a critical part of whether it's a part of a production line or just like that one spot. Why are we not getting it right across any industry?
I mean, from our experience, or at least my experience, quality issues in this space and why people don't get it right is two factors. And I think, when if you kind of peel the onion on Boeing and the issues with the Alaska Airlines, this happened there as well. So in oil and gas or any critical manufacturing setting where quality matters, the first one is typically speed is everything, and it's usually high volume. So if you look at a turnaround in an offshore platform or in a chemical plant, you could have thousands of these bolted connections that need to be taken apart and put back together. And because cost and schedule drives just about every decision that's made, one extra day or 2 extra days in schedule, that's where the biggest costs are. So what you see is the emphasis on get it done as fast as you possibly can. And that is, you do that in your daily life. If you speed through something, you're going to miss something. It's just human nature. It's going to happen. The second thing that I've seen is that a lot of times somebody else does the work. And what I mean by that is a lot of this work, because it's requiring a lot more resources or that aren't typically available at a facility, you may have to triple, quadruple the amount of people required to do this work, is that you have this sort of risk passing. And so, if you hire another company to come in and do this work, it's a transient piece of work. They may not follow the same procedure that the owner, if you will, wants followed. And so there's a bit of a mismatch on how things are done. And so you have this combination of do it fast, and then that leads to, well, I'm going to do it how I know how to do it because I can do that quickly. And maybe that's not the way that it should be done from a technical perspective, like we talked about earlier. So, why does this keep happening? I really think it's a human problem. It's not like we don't know how to calculate the required torque value on a bolt. That's an engineering problem. Those equations exist. You can figure that number out. But when you layer a very technical work process on top of hundreds of people and expect them all to do it right all the time, without any controls or any sort of system in place to have some accountability there, that's where you see problems.
Yeah, there's an old expression in project management that there are three factors that you could play off each other. There's speed, cost, and quality, and you could have two of the three. And unfortunately, in today's environment, as Mark was describing, speed and cost take precedence over quality until something really bad like this incident happens and draws attention to it. And then you start to see the pendulum swing the other way because of regulation and just general public attention and public outcry. And Mark described it really well. It's a human problem. It's not an engineering problem. We know the physics of how to do these things, but when people are rushing through things, and especially I think it doesn't get enough attention, the fact that a lot of this work is outsourced. So where you have contractors coming in, or you've outsourced different pieces of your process to third-party manufacturers, you just don't have as much transparency or traceability as you might have if your own employees who are there all the time were doing it. And as those layers of opacity build up, you have higher and higher risk of error.
And let me add to that. So as an example, to speak to the Boeing case, with the production line of 737s at Boeing, they're trying to hit a specific rate.
Okay.
And that is, getting airplanes being delivered means cash. And so the faster they can build and deliver airplanes, the more money they make. It's pretty simple. And the way they set up their production lines is really about what's my rate. And what I mean by that is kind of how many of these, and it's typically per month, can I manufacture and roll off the line and get delivered. So they're targeting, for 737s, it's probably the highest rate. Now, Airbus is the same thing. When you look at the A320s, they're both in this like 35 to 50 a month number. That's how many they want to roll off and deliver. Now, the way they set up their line, it's, they take a lot of these lean principles from Toyota and they put it into their line. So if you stand in the production line at a Boeing facility, I've never been in an Airbus one, but I've been in lots of Boeing ones, it's actually moving. It's not stationary. There's a thing that pulls the structure of the airplane along, and if you put your foot in front of it, it'll push your foot. It's hard to see by the eye, but it'll happen. So the way the company makes their money is by how fast they can deliver these airplanes. And so they're targeting these rates of like 40 a month, and so it's maybe 35 to 40 a month. So you're looking at like, let's just say 400 airplanes a year. All the components to build those airplanes, especially the major structural components like the fuselage, come from somewhere else. Mm-hmm. So what you've got is this like symphony of things that have to happen right every single time. And there's a lot of pressure because the money's made on this end and everything behind it in the supply chain affects that money making. So you've got the owners equivalent here, like a Boeing or whoever, saying to their vendors, which in this case was for 737 fuselage, Spirit, like, go, because I've got a rate to hit. Right. Now Spirit's going, hey, wait a minute, I got to deliver these things right, and I got to put them on a train, and the train takes them to Washington. And there's just so many moving pieces in here that you've got this, again, cost and schedule. How many do I need to roll out to hit my, to basically generate revenue? And how does that cascade up the supply chain? And so it's becoming faster and faster and faster and faster and faster and faster and more and more and more, because these airplanes, like, you're looking at Airbus and Boeing, they're basically 50% market share. Mm-hmm. And the demand for these single aisle small airplanes is astronomical, especially with like the MAX with better performing engines, better fuel economy, versus like the NGs and the old A320s. So there's just like an enormous amount of pressure to get it right. And one little bolt on one specific fuselage that maybe one thing wasn't tightened, this is what can happen. And, mm-hmm. It's sort of a consequence risk matrix. Like, if maybe one of the panels in the ceiling or something isn't secured and it comes out, okay, like that's a problem, but it's a manageable problem. Mm-hmm. But if it's a structural thing like this where there's safety involved, like, you can see how that could happen.
Yeah. And the thing is, we see this everywhere, because it is absolutely not unique to any of the companies involved in this incident. Mm-hmm. If you're running a factory of any kind, whether you're making chemicals or medicines or shoes, whatever it is you're making, it's that production, how much is coming off the line affects the bottom line,
That's right.
which is cash. And then everything behind it, there's a either explicit or implicit trade-off of how much am I going to spend, and spend could be time or spend could be money in getting that thing that we are making off the production line. And for every hour that production line is down, depending on the industry, mm-hmm. it could be hundreds of thousands or millions of dollars of cost, and it's impossible for that to not be in the minds of the managers of these facilities as this work is going on. And that's where a lot of this pressure comes from, and why things start, once you start not to have a problem, you start to say, okay, this is good, we could push it a little bit more, until something breaks.
Right.
And sometimes when something breaks is when people get hurt.
That's right.
And that's what happens.
So it seems like, you have both mentioned other industries and how this is a problem across industries. And so the things we see in the headlines are just a piece of something that's symptomatic across industries. So in your opinion, like, what would you recommend to any industry? Is there something we can do to fix these type of problems going forward? Is there an answer to these quality issues, or is there always just going to be a natural tension between cost, schedule, quality? Like how quality seems to me, especially in this case, because it's a safety issue, to be something we really need to focus on. So what are your recommendations to fix these quality?
So it's really comes down to two things I mentioned before, which is transparency and traceability. Companies put a huge amount of emphasis on training workers, and that's even more important as we face a worker shortage in many industries. And training is incredibly important, and it's great, but humans are humans, and even the most well-trained worker is going to make mistakes sometimes. So technology now allows us to not only train the worker and not only look at a QA process that looks at things when they come off the line or at the end, but to actually have that visibility into what's happening as the work is going on. And there's often a resistance to do that because we want to train and respect the workers who are very skilled. Mm-hmm. But we just have to recognize even the most skilled worker is a human being, and we need to put systems in place that look at each thing the worker does and make sure whatever the specification is, whatever the process is, that process has been followed. It's not hugely expensive or difficult, but it is something that is contrary to what's typically been done in the past. Mm-hmm. So it requires a change. And that's especially true in the outsourcing situation when it's not your own workers, it's not people you could be watching all the time. It's happens somewhere else, and then the equipment is transported to your factory, your facility, and you want to know what happened at that point of origin, and you need a record of that, and that's what you have to put in place.
Yeah, I mean, even with this Alaska Airlines incident, let's be honest, and here is aviation is still the safest method of transportation. Mm-hmm. And so, because of that, when something like this happens, this is why it's so critical. But, one of the things that happens in an aircraft life cycle is that they collect a tremendous amount of data on every single individual component on that plane. When did it fail? Why did it fail? Everything. And so the reliability of these aircraft is so good, this is the exception, not the rule. Mm-hmm. So in other industries where maybe reliability is not so good, or issues come up like that, I think one thing you can take away from the aviation industry is that data about performance enables better decision making. So as an example, when you say, we're going to prevent, let's say, a leak at a refinery, the business case for that is usually cost avoidance. And so it's based on, well, we had them before and we're not going to have them, however you change your system or your culture, it won't happen again. And it's a hard thing to justify. It's looked as cost. Like, how can I get through this and justify it through cost avoidance, proving a negative? It's very difficult. So I think there's a lot of things that other industries can look off in this quality space that, yes, the aerospace and space industry in general does very well. Is it's incredibly data driven. They measure everything. So when you look at commissioning on a refinery, being honest and being truthful about what was the root cause, how much did we have, how much did that cost us, and being transparent with that information to the other stakeholders in the event or the supply chain or value chain allows better decision making. And I think what aerospace does pretty well is that they think of the aircraft in a life cycle. When was it built and how's it maintained and when's it delivered, and they track all that data. I think for other industries, if you're doing construction into maintenance or construction into operations, a lot of times you're going to have a modular build, you're going to have a construction site, stick built, and then you're going to roll that over into operations. And I think one of the challenges now is because a lot of the companies are so large, they're very siloed. Mm-hmm. And I think one thing that can really help these industries is to think of it as a life cycle of an object or an entity or whatever we want to call it, a flange, a weld. Because what happens in the mod yard affects how maybe how your first couple, 3, 4 years of operations and maintenance are going to happen, and you want that data. If you look at it like a medical record, from birth to 18 years old, you have every single injection, every single visit, every single weight, every single height, and you can plot that and say, okay, I know how this person is, their health, overall health is. But if you said, I've got medical records for 0 to 5 years old, and I've got medical records from 6 to 10, and I've got medical records for 11 to 18, and they don't talk to each other, you can't see all three of them, how do you make decisions when they're 18 and something happens without seeing the entire history? And I think that's where this industry, or industries in general, in terms of quality, have to go. Is it really isn't just a person doing a task, it's really an opportunity to collect data and then use that data for decision making later.
There's an area where we work a lot is in construction. And in construction, there's a data point that's been published by third parties that there's a 30% rework rate, which means 30% of work that's done in construction has to be done twice. And there's an old dark humor saying we did it right because we did it twice.
Right.
And that has been the same way for decades, and it hasn't improved no matter how much technology we bring to it. And it goes back down to data. There's another number from studies about construction that says 90% of data generated on a construction site simply isn't used because of what you mentioned, Mark, which is silos. They're all siloed. The systems don't talk to each other. And that's something that aviation has actually done very well, which is think of things as, Mark, you used the term life cycle, but think about it as a system. And use systems engineering, or systems thinking is sometimes called, and understand how every part of the system interacts with every other part, and to do that transparently. And that's how leaders can make really good decisions about how to improve their own processes, what technologies to apply, all kinds of stuff like that.
Yeah, for sure.
So speaking of just the aviation industry in general, as you mentioned, it has a lot of public interest. It's very high profile, and in turn, it has a lot of regulations. There's government oversight. There's all these things. Is there an opportunity for such processes to be put in place across other industries that maybe aren't as high profile? What are the opportunities, in your opinion, that could help these quality issues that we don't hear about because these industries aren't high profile, yet they are still safety risks?
Yeah, you definitely need to. So the short answer is yes, there is opportunity to do that. You always want to be careful about over-regulation, and that could become a big political question as well. So but there's,
won't open that can
but
of
there's
worms.
Right, we won't open that can of worms.
Probably the wrong answer. Yeah.
But there is a balance, right? There's a balance between areas where members of the public are at risk, people who are not who are not assuming a risk, and aviation certainly is there. That's where the government has a really central role to play in regulating, as they do in these cases. You could say medical devices and medicines are very similar. I think in a lot of other industries, it has always been at the opposite end of the spectrum, where it was, well, these are people who are knowingly assuming risks, but so we might make recommendations. We do things like have organizations like OSHA, which looks at workplace safety. But it probably in many cases went too far in that direction, and there is an opportunity for both the industry and the government to work together to figure out best practices, and the government should be very active in working with industry to do that. I think in aviation you see a really good partnership between the industry, the manufacturers, airlines, and the government. And sometimes when things go wrong, it's when that partnership gets out of balance. And we saw that a few years ago in some of the 737 MAX certification issues. So sometimes when that system doesn't work well, that's when things go wrong for one reason or another. But when it's working well, that's how you get an aerospace industry that has a safety record that is just out of this world. I mean, if you went back 50 years and told somebody what the current accident rate of aircraft is, they wouldn't believe you. They think you're crazy. But the industry has achieved that through a whole bunch of different things: engineering, operations, regulation, culture. And it's a true wonder of the modern world that we've achieved that we could send hundreds of people in a thin aluminum tube at 40,000 feet where you can't breathe the air, and we do it like it's nothing. It's science fiction in many ways, but we've achieved that.
Yep.
And we could achieve that same level of safety and reliability in other industries, and we should. We just have to get there.
So, like you were talking about, the desired outcome is a system that comes together correctly, safely. And you, Matt, talked about the standard that the airline industry has and how it's the highest standard of safety. Yet, one incident happens and everybody hears about it. Why do you think that incident we never hear? If the other industries don't have such a high safety standard, then just conjuring, they must have many more safety incidents. Why do you think we don't hear about those type of incidents?
I think it's because people have a hard time relating to it. So you hear about them. There's an accident on a construction site. There is an article that will show up in the newspaper about it or on TV about it. So you hear about it, but when you hear about an accident on an airplane, almost everybody, certainly in the United States and in other parts of the world, almost everybody either has been or can imagine themselves taking a flight somewhere.
Having that shirt ripped off their
right,
back.
and you look at the videos from inside the airplane with the panel missing, and you do.
You can feel it.
You feel it. You imagine, oh my God, what would I feel like if I was there? And
I keep thinking of that boy with his shirt being ripped off him. If that was my child, it just really it gets you.
And whatever your belief system is, thank whoever that there was nobody sitting right next to that hole.
Right.
I mean that's a miracle into itself. And so it's visceral. It's visceral for people.
Yeah.
That makes sense.
Whereas most people, you're familiar with construction or how a factory works at a theoretical, hypothetical level. Maybe you have a relative who works in those industries, or you've passed them on the street. But it's not like you hear about an accident and it's that's tragic, that's really sad, but you don't think, oh my gosh, that could have been me last week when I was taking that flight for work somewhere.
Right. We both worked in the oil and gas. Like, safety is number one. So I would be hesitant to kind of overlay safety, a concern, saying it's a different level of concern for safety with a different level of concern for quality. I think the safety aspect of, say, going offshore is enormous. It's very difficult to do. There's a lot of checks and balances that say you can prove you can operate safely. We've seen it. Everything is safety briefings and how many people and don't walk under the crane and the safety rules, and they're all there for a really good reason. But I think you're right in that if you hear about something like Tesla recently had the loose bolt announcement, right, that happened. Well, there's how many Teslas are they delivering? Hundreds of thousands of Teslas? Well, it won't be my Tesla. Right. Somebody else's Tesla. Right. It wasn't me. It wasn't mine. Right. So there's not that visceral reaction. Or like, oh, well, I mean, if it's just a bolt that holds a panel, I'm like, whatever. Right. It's not my Tesla. And so, I don't think Tesla's saying we don't want safe cars, but I think because they've got hundreds of thousands of them coming out, and even on a robotic line where it's just rinse and repeat every single time, something's gonna happen. That may not be the best example in terms of manual work, but it's an example of where that visceral reaction of like, oh, that happened to me, and I can picture what would happen if my Tesla lost a wheel and I went off the road. So it's really about just thinking about quality as a holistic overlay, rather than I have a quality team and you have a quality team, and then we have to agree on whether there's quality. It's like, no, it's what's the outcome we want. Right. So.
Great. I mean, this conversation was really insightful. I thank you guys for being here. Do you have any last thoughts you want to leave us with, or recommendations for people to start implementing a safer quality control system? Or,
I mean, this is really about the kind of the culture around it and some of the things we've observed. I think recommendations wise, I would say really look at thinking about quality, not so much in how can I pass the risk and who owns the risk if something goes wrong, because at the end of the day, like Deepwater Horizon, condo, it doesn't matter.
Right.
They're going to go up the chain to the top, and that's who's going to bear it, whether it was their fault or not. And we don't have to get into that one. So it's really like, do good quality outcomes benefit everybody, and how can we think about what the cost of poor quality is versus how we're going to spend that and what we're going to do during the execution or construction phase of it. It's definitely solvable.
We need skilled labor. We will for a very long time, probably far past our own lifetimes. But we can help people do their jobs better with technology. It's not a big brother thing. It's making the world safer for everybody.
Great.
Absolutely. I like
So
that.
that's it.
Thank you both, Matt and Mark, for
Thank you.
joining
Thanks.
us.
Thanks for having us, Megan.
Special
Special
episode
episode.
of the
Special
Work Done
episode.
Right podcast.
Emergency pod.
Emergency pod. And
Emergency pod.
Yes.
So, and also, if you have any further questions or need more information, please visit us at cumulusds.com. Subscribe to our newsletter, Work Done Right, and keep watching the podcast, the Work Done Right podcast. Thank you.
I hope you have enjoyed listening to this episode of the Work Done Right podcast. Please help us out by subscribing and leaving us a review. And as always, our show notes are linked in this episode's description. Thank you for listening, and see you next time.